Hi there. Today we're going to talk about phase diagrams and low-low energy bar charts together. So first of all, we have to remember what it says up here at the top, and that is if we're dealing with a solid versus a liquid versus a gas, what we're going to be using for the phase energy. So the phase energy would be a solid is 1 bar, a liquid is 3 bars, and a gas is 10 bars. So that's for the phase energy when we do that in the low-low diagrams. But first we want to sketch our phase diagram. So for our phase diagram, we read through and it says that I have a tray of 50 mils of water at 20 degrees Celsius, and it's placed in a freezer and it turns into solid ice cubes at 0 Celsius. So the first thing I want to do is draw my phase diagram. So I'm at 20 degrees Celsius for water, and then it says it's freezing into solid ice at 0. So what I'm going to do is I'm going to mark on the side here 20 degrees, and I'm going to mark 0 degrees. And I know that I'm starting at 20 degrees, and I'm cooling that down. It's a liquid. I'm cooling it down until I get to 0. Then at 0 degrees, it's going to freeze. Now, whenever I have a phase change, the temperature does not change. The temperature remains constant. So here, my temperature is going to be constant until the end. And now at that point, I have frozen ice. So if I wanted to, I could even label the different parts here. I could label this A, B, and C. Now, from A to B, I would have a liquid that I'm cooling. From B to C, I have a liquid turning into a solid. And therefore, I know that BC is going to be my freezing point. So right now, I have my phase diagram done. Now I want to do my low-lows. So for my low-lows, I can think about this as being, okay, this first low is for A, this second one is for B, and this last one is for C. So for the first one, I have a liquid when I'm at A. So when I'm at A, I have a liquid. So I'm going to go ahead and make a squiggly line to show I have a liquid. And I think I'm going to use 2 whooshies to indicate the speed of my particles. And I could use an arbitrary amount, 3, 4, 5, 10 particles. Don't worry about getting like 20 particles or something. At B, I still have a liquid. It's just that it's colder. So because we have thermal expansion and thermal contraction, it's going to be just a little bit lower in terms of volume. And since it is a lower temperature, I'm also going to have fewer whooshies. So now I've got a liquid. Still a liquid, I should say, and it is moving slower because it's at a lower temperature. In C, now I have a solid. So that solid, remember, is going to be very ordered. So I'm going to go ahead and draw the particles, very ordered. And I'm going to go ahead and I'm going to draw little parentheses around it to show that the particles are just vibrating when we have particles of a solid. Next are the energies. First energy that we have is phase energy that I like to do first because that's really easy. Phase energy. Phase energy, as we set up here, for a liquid, we're going to use 3 bars. 1, 2, 3. Here we still have a liquid, 3 bars, 1, 2, 3. And over here we have a solid, so it's only 1 bar. Now, going from A to B, one type of energy will change. We already see that phase is not changing, so it must be thermal. Makes sense because when we have thermal energy change, that's because the temperature is changing. So the temperature I'm going to start out with, since I'm at 20 degrees, I don't know, I feel like doing 4 bars. It's kind of arbitrary. You get to pick however many you want. Since it is the temperature here is decreasing, so if I'm starting at 4 bars of thermal energy, then since the temperature is decreasing from A to B, I have to use less bars. So I don't know, I feel like using 3 bars here from A to B. So now I have 3 bars of energy here. Now notice, it's thermal energy that's changing from A to B. You can only have thermal or phase energy change. You can't have both of them changing at any point in time, changing both of them. So therefore, from A to B, it's thermal. Now, from B to C, now I'm changing my phase energy. I'm starting with 3 in B, and I'm ending with 1 in C. So since I'm changing my phase energy, it's got to be the thermal that's going to remain constant, which makes sense because if I look back up here at the top, here I have my thermal energy changing, right? When I'm going from A to B, and when I'm going from B to C, the thermal energy or temperature is not changing, it's the phase energy that's changing. Okay, for the second set of phase and lolo energy diagrams, we have to remember once more that solid for the phase energy is going to be 1 bar, for liquid it's 3 bars, and for gas it's 10 bars. So we go through here and we read the information given to us. So it says a pan of 2 liters of water at room temperature of 25 degrees is heated to boiling, and then the steam is heated to 125. So we have to remember a few things about water. First of all, its freezing point is 0 and its boiling point is 100. So if I'm starting at 25, I can go ahead and put 25 on my diagram if I want. And at the end, I'm going to be at 125. I'm also going to have to stop somewhere at 100 in order to do a phase change. So if I'm starting at 25 degrees right here, I'm going to go ahead and go up to 100 degrees. And then at 100 degrees, something happens. Boiling happens. And it's going to boil. And then once everything's boiled, now that steam can heat up. So I can label these A, B, C, and D if I want. So during A to B, I know that I have a liquid. During B to C, I know I have a liquid and a gas. And then during D, it's just a gas that I'm heating. So stop for a moment and think about what type of energy is changing from A to B. What type of energy is changing B to C, and what's changing from C to D. All right. Now, attempt to fill out some of your low-low diagrams. We're going to have here A, B, C, and D, different parts on the graph. See if you can go ahead and start with A, with the particle picture, then do the particle picture for B, then C, then D, then go back and do the phase energies. Hit pause to do that now, and then go back and check yours against mine. Okay, so first off, I have my liquid, and I am starting out at a low temperature, so I'm just going to go ahead and use 1 whooshy. And then at B, I still have a liquid, but it's a little bit warmer, so I'm going to show thermal expansion just a little bit. It's warmer, so I'm going to put 2 whooshies here. At C, I no longer have a liquid. It's turned all to a gas because it's a liquid at A, it's a liquid at B, it's a gas at C, and it's still a gas at D. So for C, I want to have a gas, but it's the same temperature as B. B and C are the same temperatures. So I'm going to use the same amount of whooshies. So here's my gas at letter C. Okay. Then for D, D is at 125 degrees versus C was 100. So I need to add extra whooshies. So I'm going to go ahead and put 3 whooshies on my particles over here. Now I can go back and I can do my phase energies. So for my phase energy, remember, we're going to use 1 for solid, 3 for liquid, and 10 for gas. So here I have a liquid, so I'm going to do 3 for liquid. I still have a liquid, that's 3. I have a gas, so that's 10. And I have a gas, so that's 10. Okay? Now, for my graph, I can even go back up here and remind myself, yeah, phase energy is changing from B to C. So during A to B, it's actually thermal that's changing. And during C to D, it's thermal that's changing also. Because remember, thermal is something that I can measure with my thermometer, like temperature. So over here on the left, I'm starting out at 25 degrees. I feel like using 2 bars for 25 degrees. I'm heating it up to 100. So I'm going to go ahead and I'm going to use 4 bars at 100. Now, at C, I'm still at 100 degrees. So I still need the same amount of bars, 4 bars. At D, I'm at 125 degrees, so it's hotter. So I need to increase my bars. And I know that's not exactly to scale, but I could have 5, I could have 8, I could have 10, whatever I want here, to show that it has increased my bars of thermal energy. So that's a review of thermal energy and phase energy, also of phase diagrams and lolo diagrams. See your teacher for more help.